I have a very brief update on some changes that have been going on in UEFI land, and then thankfully, in order to fill the hour, half hour, 25 minutes, Art randomly came up with some interesting discussions about secure storage with UEFI, memory protection with UEFI. Right, so the first thing, can someone please close the door? First thing, I've been speaking about Open Platform Package in the past. I'm now here to tell you that it's dead, it's going away. And the reason it's going away is because it's achieved what it was set out to do in the first place, which is it gave me the ability to prototype setting up a single tree with support for multiple platforms for EDK2 until we actually managed to sort out the situation of getting platforms up into the public Tiana Core trees. And we've actually achieved now that the guidelines and the documentation and the official process for how we're going to treat open platform support with EDK2. The repository is already up there on GitHub, and so far it contains a readme.md, which basically explains the process. So I lied, there's actually two repositories. We do have some platforms that are not completely open source, so they contain some binary-only modules, which, because of the ABI guarantees that UEFI gives you, is still possible to have and still rebuild against newer versions of EDK2. But because of basically it is unacceptable to many of the UEFI forum members and the EDK2 contributors and participants to have these binaries in the main tree. So we're splitting that out into a separate one called EDK2 non-OSI. Neither of these are forks of the EDK2 repository. They're standalone subdirectories. But there is a function in the EDK2 build system, well, a function as in an environment variable you can set. It's called packages path, which means that the build command goes through and looks in all of those places, so you can seamlessly integrate multiple repositories like that. For the actual EDK2 platforms, one of the reasons it took so long to agree on a process is that we're trying to bring together two quite different development communities. We have the traditional BIOS and UEFI developers who are basically used to having some sort of underlying base project, and whether that's the commercial BIOS developers who have their own fork of EDK2. But anyway, checking that out and then basically taking 10 different zip files from 10 different vendors, unpacking into that directory and working with it there. So because that model doesn't really scale to carrying multiple platforms in the same repository in the same branch, they want to be able to keep that workflow with the new system. And of course, I'm fairly convinced that they will see the benefits of not doing that in the future. But at the same time, I was quite strongly feeling that the entire point of this is that we can stick multiple platforms, preferably all of them, into the same branch, so we can see where there's code commonality and we can start breaking out a lot of reinvented wheels and just getting them into main EDK2. We used to make UEFI releases in Leg. And last year we kind of silently stopped doing that. It was a reasonable amount of overhead doing that, but also we got the reference platform releases coming out, which had to include firmware as well. So we just sort of basically leaned on those guys to take the heavy lifting and work together with them to get those releases out. So we're not going to go back to making any more leg releases. That's all going to be through the reference platforms work. But doing this with the enterprise reference platform work has also perpetuated the broken mechanism that has been endemic in the ARM UEFI ecosystem, of treating firmware as software. So we've been making releases. Now you're supposed to boo at that point and applaud a bit later.
No, I'm applauding you in advance of where you're going.
Okay. So we've been basically releasing fully vertically integrated software stacks of industry standards compatible interfaces, right? It inevitably leads to bad habits and bad practice. So we did that for 2016-06 and for 2016-12. There was some reason we actually had to do that, right? In order to be able to support some of the ACPI features, we kind of had to move things on both sides of the fence up until the point that we actually got stuff merged into the Linux kernel. Since Linux 4.9, we're in a very good place. We can move away from that now, which means we absolutely have to as quickly as possible. And from now on, we will have the firmware releases will be leading the ERP operating system releases by 1 to 3 months, starting with 2017-04, which is going to be the next one for the 05 or 06 software stack. I will be on holiday until 3rd of April. So basically, any firmware patches, ACPI table updates, anything like that you want to have in platform supported by the ERP release in May or June need to have hit my inbox by the 10th of April. That's mainly all of the stuff that we're doing in Linaro, but I have a couple of slides of other stuff that's happening in this space. The main thing, I think, is ARM has released what's being called the Architecture Compliance Suite. It's already on GitHub, but that is the alpha version. It builds, you can make it work, but it's not entirely complete, and there might be some rough edges. It provides validation of SBSA and SBBR compliance. The SBBR portion is based in part on the UEFI SCT, which, as we know, is still available only to UEFI forum members, although we're working on that. But for now, if you want that part of the test framework, you need to be a UEFI forum member and get your code from there. But actually, I would say the majority of the SBBR tests consists of the firmware test suite integrated into LoveOS. So we're all basing this on the upstream LoveOS project with a few patches. The SBSA side, that's a lot more bare metal type level of testing, so that's sort of a standalone thing, but we build everything under the same environment and we include that into the same image. The current LoveOS release is based on Linux 4.6, and as I said in the previous slide, we were in a bit of a problematic situation until 4.9, so there's a reasonable amount of kernel patches stacked on top of that 4.6 kernel. The next release of LoveOS is going to be based on 4.10, again, at which point we can throw all of those patches away and just use the upstream kernel. It says 4.9 there because when I wrote this slide, that was true. Basically, the next release of LoveOS has slipped to the point where they might as well use 4.10. But I think they promised me that it was going to go out, I think, code freeze this week and release next week.
And they'll have the quotes in for PCR?
Pass, if it's in 4.10, yes.
It is,
yeah.
I think we're okay, but 4.9 would have been different, so that's actually good. That's actually good.
There was one console SPCR thing as well that we got in 4.10 that we didn't get in 4.9, which makes it even better, yes. With currently, well, ARM is currently upstreaming SBBR tests to firmware test suite, which is owned by Canonical, if you didn't know that. And so for now, we still have patches on top of firmware test suite in this, but we're hoping again to get rid of that as much as possible in the future. So there will be basically a -- SBBR command line option to the firmware test suite, which will change some tests from verify that this table is valid if it exists to fail if this table does not exist on this platform, and a few things like that. Adding tests for another few trees and tables and so on.
What do you test for root time services?
That's the SCT.
Oh, the SCT has root time services.
Yes.
So
Yeah.
was the only for one time.
Yes.
And, on the Redhead side, we do run FWTS in we have our beaker lab system, lab management system, a bit like Lava. We do run FWTS in there as part of our tier 1 build tests. We are going to be running the ACS tests as well. In fact, all of this will run, and so every time someone sends us a platform, the first thing we do to validate it is we put it through our tier 1 testing. What we will do is we will run all this. Sorry. What we'll do on the Red Hat side is we'll basically run all of this stuff on anyone's proto platforms they send us, because we kind of do that already for FWTS. But if they send us something and it doesn't pass all of these things, we're just going to say, you failed, it's broken, we're not interested, come back to us when you have it, when you pass all this stuff.
Cool. Final slide, which is kind of big. Grub. Grub has been a problem child for a while in that there hasn't been an upstream release for 3.5 years, 4.5 years, which means basically a lot, if not all, of the AR64 and ARM support has not formally been part of a released version, and lots of bug fixes, improvements of UE5 support, and so on. That's not been there. But last September-ish, there was an announcement that Vladimir, who's the head maintainer, was going to pick up 3 new sub-maintainers to help him speed things up and clear up the backlog and actually get a release out the door. And on the 3rd of February this year, the RC1 was tagged. Now, the intent was that the release would go out in February. That did not happen, but it's clearly moving along. The other thing, which is possibly the big news, is that there is now a proposal for how to integrate image verification into the upstream grub. Because we've had this horrible situation for years now where all of the distros have their own local copies based off some stuff that Matthew Garrett threw together a few years ago, and they're all diverging, and they're kind of sometimes behaving similarly and sometimes kind of not. And obviously having that situation and a security feature is extra undesirable. But there is now a proposal for an abstraction layer to deal with both the GPG signed images which Grub supported in the past, but also TPM measured boot and actually integrating support for the shim protocol. And that is going to be a huge improvement for everyone.
So one thing on the grub side is a really big kudos. Really kudos to the grub developers. If you've ever had a bad experience on submitting code to grub, which is basically a given if you've ever submitted code to grub before, that's changed a lot. They're actually responsive now. They review your patches. They have good comments, and they do take patches. You don't have to have 500 patches on top of upstream grub in a distribution anymore. So if you own a distribution, make sure to flush your queues, because now it's possible. Before it wasn't.
And to be fair, I think that's part of the reason why this release has taken so long, because they are genuinely going through the bug list on Savannah and trying to close out everything before they get the release done. So they're not just dragging their heels, they're dealing with the fact that they haven't done this for 4 years. And that's all from me. Any questions? Okay. 2 sudden ones.
Plenty of questions. Hi. First of all, do we still need grub when we have UEFI? What's missing in UEFI that doesn't exist in? Sorry, what's missing in UEFI that?
It's not a question of missing. It's a question of it's a useful abstraction layer. That's all it is. Yeah.
Can you clarify? Can you clarify that?
I can, but that's going to take quite long.
Well,
Right.
let's take it offline.
But that's the basic answer to your question. It's a useful abstraction layer. Do you fundamentally need it in order to boot the Linux kernel on a UEFI system? No. But it's a very useful abstraction layer for distributions.
Okay. The other question, I think that was mentioned by Linaro's CEO, EBC compiler support for cross-platform drivers. Will there be a Linaro initiative to develop one from scratch, or is it like are you guys waiting for a contract to do that, or is it a possibility? The one that's the only one is the Microsoft one, and it's not even supported anymore. So what do we do?
No, it's the Intel one.
Oh, Intel. Sorry, Intel. Yeah. So what's the story here? What's the plan for Linaro?
So we have drafted a plan for how to develop this based on LLVM. What we haven't done is resource that plan, and that's a question for the steering committee to decide when and how to do that.
Okay. And then the final question is, can we do self-hosted ARM UEFI development today? Can we compile an ARM UEFI on top of an ARM machine?
This is an ARM32 Chromebook. Apart from Itanium, I kid you not, I also compile and run my AR64 UEFI on that one. And I actually have an AR64 QEMU that I use on my 32-bit ARM to test that the 64-bit UEFI works.
Cool, thank you.
Mine's a quick one. It was about at the beginning you had the open platform package being moved into the Tiano Core upstream trees.
I'll do that.
I was asking for a timeline and that sort of thing.
The timeline is ideally by the end of last year.
Well, I realise that.
Realistically, it's going to be. I guess I'm going to have to go into hiding immediately after the April release. That's probably the only way it's going to happen.
Yeah, that's fine.
No comment. Okay, I'll hand over to Art. If you have any more questions, we can take that later.
Okay, so I'll just run through a couple of slides on the work I've been doing on the side over the past year and a half maybe to improve memory protection in Tiano Core. So this may be a bit sensationalist, being under attack, but I've been working on this topic, not necessarily in UEFI, but the kind of embedded platform security since 2009. And back then it was quite difficult to get people excited about securing their memory and explaining that there's more than copy and write or that kind of things that can actually make use of a read-only bit in your page tables. So, yeah, I think this is, I'm not going to read all slides because we only have a couple of minutes, but the idea is that because the kernel is getting more serious about memory protection by default, it makes sense to do the same in the firmware, because otherwise you just move the problem around. So, this is the current situation basically. If you have well, in Linux kernel we're quite serious about locking things down more and more, and I'm actually pushing on patches on the kernel side as well to even improve that a bit more. And the kind of ultimate goal, because when you're loading you have to load stuff before you can execute it, but the ultimate goal is to have as few regions that are writable and executable at the same time, because that's basically the biggest issue. On the UEFI side, they basically never cared, so everything is just read, write, execute. So for the regions that the kernel actually maps, but which are basically owned by the firmware, we have a new table that was specified in 2.6, where in addition to the UEFI memory map, which describes the nature of those regions, there's a table on the side that for every runtime data or runtime code region tells you which parts inside those regions you can map with either non-exec or read-only permissions. This does require the section alignment to make sense, so it also implies that on ARM64 your peak of binaries need to have 64K section alignment, which is already more or less mandated in the spec anyway, but it's something you have to take into account explicitly. So we have support for this table in 4.7, and the Intel guys are catching up now, and they have enabled it for 4.11 as well. The DXC non-executable stack, so this is like the firmware phase where all the drivers are dispatched, and which spills over into BDS, where you're loading stuff from the network, loading stuff from the disk, doing other stuff which may involve untrusted data. So there was support added for mapping the stack non-executable. And I enabled that a while ago for ARM64 in the third QEMU reference build and some of the platforms we have in Open Platform PKG. And actually the patches that are pending for 32-bit ARM, I just merged them the other day. So, and I have a patch on the list for Ryan to test on the 32-bit ARM to actually make sure that it works on real platforms. But then we have the stack map non-executable. This is like the peak of image protection is like the boot time counterpart of the memory attributes table, where you build your peak of, so standard peak of images have very small section alignment, which is not even allowed by the PECOF spec, by the way, but it seemed to work, so they just hard-coded that everywhere. And recently, one of the Intel firmware team engineers implemented peak of protection, where you build your peak of images in a way where you can meaningfully separate code and data and map the code read-only and the data non-executable. Mapping your peak of images secure doesn't make a lot of sense if all other memory is mapped read, write, execute. So because the Intel guys seemed serious about fixing this, I kind of jumped in and proposed some patches that basically just map everything non-executable unless you're going to use it to execute something from, and then it gets remapped executable. This broke some stuff, so it's not something we can enable by default completely strictly, because, well, grub assumes that it's anything it allocates it can execute from, which is not entirely unreasonable for a loader, so it does make sense that they did it that way, but it's still something we may want to fix. Well, one thing to mention here is that because the way we wire up grub with shim and all these circumventing normal load image controls enable to do verification against the shim certificates rather than the firmware certificates, and UEFI doesn't specify manipulation controls to actually tighten down the peak of image protection. Really only works for OS loaders that use a normal load image interfaces. And if we want anything on top of that, we need to do it, well, we need to work on the spec side first.
Has any of that spec work started in terms of to address the bottom point?
No. No, but it's just literally stuff that I was doing last month, and I thought, okay, let's whip up some slides. Okay, just to have the whole end-to-end picture, I'm doing some work on the Linux side as well. So because the kernel image poses as a p-ecof binary as well, you have to enable the same kind of section alignment and mapping attributes in the p-ecof header to make sure that only the stuff that, that you have the strict split between writable and executable. It makes sense. Well, it's under debate whether how far you want to take this. I mean, if you're really early and you have to do some mappings that are right to read, write, execute, but you're not consuming external data, or you're really just setting up the page tables, maybe it doesn't matter. So have some. So basically the top part is patches that are currently under review and probably going in, and then I have some RFC patches out that do some ungodly things to move the kernel around, so it happens to land on a section boundary, so you can map one side of this, the section boundary read write and the other side read execute. I'm not expecting that to be acceptable to the maintainers, but I may get surprised. Any questions? Okay, thanks.